Hi, I'm Jennifer, and I'm at the Moses Wilder Blacksmith Shop in Bolton, Massachusetts, and we are going to make a set of dividers today. And what I have here is it's a pattern book. This is a wonderful book. If you are a blacksmith or interested in history, this is a wonderful, wonderful book because it has all patterns in it of the early equipment. Well, it can be hard to actually figure out how to do it through these photos, or I should say sketches. It still gives you an idea of what was popular. These kind of pattern books were everywhere, and you would actually go to a store and order it through these books. This book was produced or authored by Jane Reese and Toby Hall. So basically what we're going to do is we're going to get this forge started, and I just use a little bit of paper and a little bit of kindling. I like doing a mushroom, which basically you just layer the paper up, and then I just start squeezing it from the center. And I create a mushroom with a tail. You should always be checking your air to make sure you actually have airflow going into the forge, because sometimes they can be shut off, and this is an important part. So you want to light the tail and then just add a little bit of heat. Get that going with the stack. A little bit of air.
You can adjust the valve gate in the back too.
What was that, Bob?
You can adjust the valve gate.
Is it already opened or closed? You already mean as far as how much comes out?
Take a look.
As long as I get air, that's the important part. So as a blacksmith and using a solid fuel forge, one of the things that we have to do is actually take care of our fire. And a fire has to be fed. So as we're feeding it, we have to keep mounting up the coal to keep feeding it to create coke. And coke is the product that actually swells up. And that's what we're actually burning. So we're not really burning the green coal, we're burning the coke. And that's what I'm doing right now, is actually creating the coke. So what I'm doing right now is I'm going to cut the bar into a more manageable size. So you can see, even with that small of notch, on how easily I snapped it off. So what I have to do now is, because this bar is larger size than what I want, I have to do a reduction in size. Anytime we're reducing stock, especially wrought iron, because this bar is wrought iron, we have to reduce it as a square. So each time we hit it, we're trying to keep that pressure even on both sides. So right now, we're just about a 1/2 inch. And we're going to use a 1/2 inch for the center section, but we're going to only use about 7/16 for the double side. I wanted to talk about my rule a little bit. Now this is actually known as a blacksmith's rule, and it comes in 2 feet. Now there's a reason why it's actually brass, and because when we take a measurement, you can take a measurement. So say we've got a measurement of 2 inches. What I do is I take it, and now I actually have that mark built right in. So now you can see when I go to mark it, I already have that mark. Now say I got 2 inches. Well, now say I want 4 inches. Same deal. See again, now I can see I marked it again. And that's why these were brass originally. Ease of manufacturing too, but this was one of the primary rules for it, or the reason why. So I still need to create a little bit extra length. Probably one of the most interesting things that I find anytime filming or working at the anvil is the metal spends more time in the forge than it does at the anvil. Usually it's a ratio of about 2 to 1. This is typically what would happen in old school blacksmith shops, because you wouldn't have the right size stock, you'd have to make it. So in the olden days, they actually had ironmongers that would come around and they would have like 5 sizes of stock, that was it. you had to make all the sizes in between. Okay, so what I'm actually going to do now is I'm going to start, I think I've got enough material. So I'm at my 7/16, a little bit large there. Yep, so we're good now. So what we need now is we have to have our initial measurement. Believe it or not, we're actually ready to create our first wing. Okay, so what we're actually making is a dual wing set of dividers. And so you can see here, Roemer double joint compass. These are single joint. So what happens is they are offset. And they're offset, this is actually a sample from a dual joint, but they're offset, they only have one side each. So each side only has one side. This is actually a double. And so what we're making today is a double joint. And so we are making this style with a double joint. The process is rather neat because it's actually forge welded together to create this. So this is the style we're making. We're going to start off with about 2.5 inches of stock. And again, now with my nice brass ruler, you can see I marked it. And also what I'm going to do is that these are forged opposites. So one has to go this way to create the angle, and the other one has to go this way. The problem is that I always forget which is which. So we're going to start going this way first. And I just put a little mark in it. So what I'm doing now is actually setting the shoulder some, because I won't be able to get back in there once it's together. So I'm going to come in and just knock that down ever so slightly and get the angle that I want. That one on the side. And again, they're opposites. So now what we're going to do is we're going to forge weld them together like so. So what I'm doing is forming the scarf. The scarf is what's needed to have a clean weld. So you can see how thinly that I actually just brought that down or forged it down. So that's actually going to be the scarf, and that's how it's going to be welded together with this other piece. So we have got a right and a left side, and this is going to mount on the top as soon as I get that scarf shaped a little bit differently. Like I said, because I don't use any modern tools, I have no way of holding this together while I'm actually welding it. So I actually have to create that mechanism to be able to hold it together for the weld. And so I actually need to shape this the opposite to make sure that it's nice and flat. And we want this to be in perfect contact to get the best weld we can. So you can see how I just brought this all the way in line with the center, because that's where it's getting welded. A little bit of cleanup. A little bit of borax welding flux. So now what we want to do is we want to make sure that we have everything in alignment. The inside section, which I don't know if you can get a shot of that. I really can't hold it that easily. Maybe I can. There we go. And again, because I'm not using any modern methods for tack welding together, they need to be held in order to get the weld in. If you have several people working in the same shop, it's a lot easier because they can actually heat the metal up in another shop or another forge and then bring it over when it's reached welding temperature. We don't have that advantage here, so we want to make it as close as we can to being what we need, and that's going to pretty much do it. Our centers are in alignment. You can see that this is pretty good. So I'm going in for my first welding heat, which is the tack heat. And again, all we're looking for right now is just to get a tack weld. We're not looking to get a full solid weld. I just need this to be held together so I can finish the weld. What I just did will allow me to take a better heat because now I've actually placed the material, the metals, in close proximity to each other so the heat will transfer between the two. Where before with that little bit of airspace in between, the temperature could be different between the two pieces of metal. So I've got my tack weld. Hopefully it's tack welded, don't know yet. It's still together, so that's a good sign. Now I'm going in for my full weld. And now we have to be really careful because our eaters are actually in the fire and they're thinner and they can burn off. So our alignment in the center is nearly smack dab on. Couldn't get much better in the center there. If you had two people doing these, one person doing one side and one person doing the other, you'd probably get them done in 15 minutes. It's interesting that working in your fire pot, the air has a tendency to be a little bit towards the backside a little bit more. because I am having to forge weld this down, I need a spacer to go in between because otherwise I won't have a way of holding it. So I need something that I can actually squeeze together in the middle. So by putting in that 1/4" bar, now I can squeeze it and finish up my weld, which looks really cool, by the way.
Very nice.
So as I'm welding this now, I have to be careful because I can actually shift the center of the joint one way or the other depending on which side of the material or metal is colder than the other. It's always interesting to me on how forging is really such an on or off sport. You know, it's an on and off kind of deal. That you're on for a split second. It's like a sprint to the endurance race. Because you have to be able to swing a hammer for a long time, but yet everything happens so quickly. What I'm doing now is actually starting my initial taper. And this is starting to come into the finishing heats. What I'm going to do next is actually weld on a piece of tool steel to the end so it can actually be used for scribing as well. But while I'm actually waiting to do that, I'm going to do the second jaw, or the second part of this compass, which is the other side. So that's pretty good there. Now it's a really, really long time. And it's so amazing to me that any of this is possible. You know, that literally any of it's possible. It's almost like every time I see blacksmithing, like watching a good blacksmith, it's like I turned 8 years old again. The first time I saw it, I was like, oh my God. And I'd rather watch a good blacksmith than actually do it. I love them all. So what I need to do now is actually go through and start doing the other side. So we already know we need a certain amount of material for the wings. So what you really can't see is that the center section is wider or thicker than these two sides. And so when we're making that middle part has to fill that width. So ideally, this should be 1/3 of the overall width. So 2/3 would equal these, and 1/3 would be the middle. And that's what we're looking for as far as thickness goes. The neat thing is, well, one of the neat things is that this should be a full taper. These are a little bit thin on the ends, but that's fine. We might be able to clean that up with a rasp, or it may not be exact, and I'm okay with that. But so the problem that comes now is getting the right amount of material to form the center section. And right now you can see we're a little bit small here. We'll never have enough material to fill that. So I'm probably going to upset it, which probably is not such a great idea. Rob, do you mind if I just cut the bar? Never mind, I'm not going to upset it. So the reason, upsetting is any time you are taking a skinny piece of material and you're making it shorter in length and fatter. And the problem becomes that wrought iron, when you go to upset it, it actually takes all the fibers and it basically takes them from a straight fiber and knuckles them over onto themselves. So what happens is that it creates this really cool pattern internally, but it can actually delaminate on some of those striations. So this is actually a little bit different because now we actually need to know the angle that we originally had set up. So we're here, and so we're actually going to go there. Let's see if I get it right. That way, not that much material. Yeah, I got it right. So the angle that I have to put in has to match this. So you can see that this is an angle. That angle has to match that. Okay, we've got plenty of material thickness here, and I don't care that we're going to end up with a little more length. That is perfectly acceptable. Anytime you're doing these, the important part is shoulder here, and right here. Those have to line up. There has to be enough material to go through in order to smooth it off so that it's even from both sides. That's a nice looking quality tool. There. By me taking my time, I'm actually allowing for it to cool off. So right there, the part that's in the vise doesn't get as distorted.
Now you're just shouldering it?
I am just shouldering it, yep. I'm trying to refine my shoulder just a little bit more because it has to be crisp. That looks pretty good. So because of setting the shoulder now and doing it in the vise, I need it to be nearly welding temperature, especially because of the wrought iron. That's great. Okay. Awesome. So as I'm hitting it, I'm actually turning it and moving it because this will have a tendency to deflect as I'm actually working it. So So if I hit it, it'll actually do this and then this and this, and then eventually it'll snap off. So I want to be paying attention because we're almost done with that. So what I'm looking at now is actually the thickness here to match that. Okay, so our thickness is pretty good now. So we're going to stay right there. That can be filed. That should put that where that belongs. Okay, so overall I'm very happy with where we are now there. Now it just comes to cleaning things up a little bit. That is nice. Okay. Ideally, anytime I'm cutting off a bar, I want to cut it off so that it's ready for the next job. So these two pieces are pretty much forged to shape. What I'm going to do now is actually add on the steel bits to create the hardened tool steel edge. So what I'm doing now, this is actually the steel that we're going to weld on, and I've already forged the scarf, which is here, right here, that's the scarf, and this is going to match the scarf on this piece which I forged in earlier, and of course I put it on the wrong side, but that's alright. You can see I put it on the, it should be this way, the scarf should have been flat this way instead of going the other way. So what we're going to do is we're going to attempt to forge weld these two together. I don't ever do anything the easy way. I mean, doing this the easy way would just be taking out the arc welder, tack welding it in place, and then being done with it. You know, because then you can just hold it in place and weld it. I don't do any of that. We'll just see if it's a fakey weld. Sometimes the flux gets hot enough and then cools off enough that it actually seems like it's welded, and then you stick it in and it's not.
It's glued with.
So because my material was already a little bit thinner in that spot than I liked, what I'm going to do is I'm going to upset it so I'm right, localize it, and upset it. And what that'll do is it'll test the weld. If the seam pops, I'll be able to weld it because I'm putting material back into it. Which is kind of cool. This is one of those little actions which is amazing to know. Most people won't upset their weld because they're afraid of it shearing or falling apart. But if you notice, I've already gained back some of that size where it was narrower. Those are the famous last words of the blacksmith, by the way. Just one more heat. Just one more heat. I was joking around with someone, and they said, "Don't say it! Don't say it!
Just do it.
Just one more heat."
Where are those sparks coming from?
Oh no. So it must be a good weld because the weld didn't pop and you can see it's all the same color. So a forge weld will always fail on the scarf. It won't fail in the middle of the weld, it'll always fail on the scarf. The scarf is the starting point for the evacuation of flux and other impurities between the two metals. And a weld will always fail at either end of that scarf. Don't touch that, that's still hot. I always think it's interesting working in other people's shops because their tools are just slightly different. Like on my hop cut, it's a very narrow. And so when I'm working on yours, I have to be careful because I have a tendency to hit it and then it just shears apart. So I always got to remember to, put a little more heat to it, just like that. Curse you, tiny toilet. Now what am I going to do? That's a good question.
I'm impressed.
You mean I got it on the first try? That's still hot, by the way. So you can see we're not too badly off.
No.
Let's see if I can.
Oh, that's very nice.
Pretty good.
Bad.
Yeah.
So each step is merely refinement on the one before it, on the one before it, and the one before it. And right now we're at the step of actually coming in, and if you look, this is not straight anymore. See that bow back here? Don't care about up here, but right here, see that little bow?
Yep.
That'll affect where this actually sits in relationship to the center line. So I need to get rid of that. And that's the next step. If you look at this one, on the other hand, you can see this one is already in pretty good shape.
It's a straight cut.
Pretty close. Okay, now what happens, because we have to rasp or file all this down, we can be off some and it's still okay. think I'm going to leave that. Okay, overall I think I'm happy with where we're at in terms of what's going on here.
Wow.
Very much so.
So now comes the time-intensive part.
And you deliberately left it tight so that when you finish it, it's fine.
I will have to, there's actually a step that you go through. So what you do is you file it, you clean up any of the nuances, you make sure that it's fitted well, and then when it's cold, you actually come through and hit the top of it.
Right.
And you actually, it's cold forging. It's part of the finishing process. They still do it today, but you don't see it very often, is where they would stack discs together and then flatten them all together, and that creates the same thickness plate. It's really very, very neat, but that's how they make sheet metal. And so by doing it that way, you're actually guaranteeing that your faces are perfectly matched. The idea is that because the surface between the two joints there's so much surface area that it's all making contact in minute parts, and that's what smooths it out. Again, since we're doing it all by hand, the guys that were professionals that were doing this, I mean, everything was just, to the thousandth of the degree. Like really, they would file something flat and you could put a thing on it, but they were doing it every day. So really, it's just such an amazing, amazing thing. So the important thing about these is where this ends, the angles here and here, and then where it ends in the back. So you can see that if I hold it like this, that they're pretty close.
Yep.
Okay, now watch when I go over. See, they're almost as close. And when I go this way, you can see that it lines up. And again, this is not filed. This isn't any finishing work at all. I didn't do anything to create, other than forge, that. If you look, you can see where it's almost full. See where that middle section is almost exactly where it belongs?
Yep.
And so that means our forging was correct. And even our length is pretty good.
Yeah.
Okay, so that's that. That's actually the forging part. Okay, so what I got going on here is just had lunch. No, just kidding. I did, but file. What we're doing is the final aspect of doing the fitting of the joint. So first thing is cleaning everything up, get some good numbers as far as how things look. Okay. So at this point in the game, what I'm doing is basically just cleaning things up, or bearing surfaces that we're looking at for how things fit together. I need to have, or see, what aspects need to be removed. So you can see here that when I go to close, it doesn't close. So you can also see that this is too high. So that needs to be removed there and here, but you can see it's nice and even. So that's really good. And then once I do that, because these have to be meshed and fit perfectly, or reasonably so. So that's what I'm doing now, is setting up all of those little parameters. So this angle here, where it terminates, should finish right here at the junction. So we don't want to have this off any. When they interlace, the other wing should fit and actually match that. So they're going to end or terminate exactly in the same spot. Once you get, we're not there yet, but once this joint goes together, once it fits properly, you actually take your hammer, and before there's even a rivet, you actually take them and flatten them. And once you do that, you put the rivet in, and then you basically do the same thing one more time. So the rivet goes in, cinches them together, and then you come through and hit them one more time. And then you do last adjustments, and they're pretty much done at that point.
Okay.
Really, it's a neat process. Once it happens, it's like, And this is the hard part. If I was a professional, I'd have an angle gauge out here. I'm doing it that way instead of by eye. One of the nice things about this kind of wing divider or compass is that because they have such a large contact area, they are very stable. You know, the joint and then the tips are very stable. Once it's riveted together, they're just really flawless. It's just such a nice piece. So again, you can see in the joint how that is filling in the bottom. This middle leaf is actually filling in that joint. When we come over here, you can see we're making intimate contact in here. So again, all these pieces should be pretty much in contact by the time it's fully fitted together. This is the part where it gets starting getting scary because of the level of fit up. So now you can see I finished off the root, or pretty close to finishing off the root. So our connection piece here to here is very even as far as the bosses go. You also notice each time that they go back together, they're fitting tighter and tighter together, they're sliding together better. So what I'm doing now is I'm actually creating pressure points that you can actually see between the work. So you can look, you can see there's a pressure point there, there's a pressure point back here, you can actually see where they're hitting each other. Here and here. So those are the parts that are high and need to be taken down. Isn't that cool? Look how tight the joint is. Now what I'm looking for is there's a wear pattern, like I was saying before. And you can see, look how even that is. So from here to here, you can see that the wear pattern is completely even. If you look here, the wear pattern is a little bit more outside, right here. See how that one's straight across? This one's just at the very end. If you look here, you can see the wear pattern is exactly the same, or nearly so, from side to side. See how there's not very little wear in here though? That's corresponding to that side. So when the two go together, that's actually the part that's hitting. See how they meet together now? Mm-hmm. So that's the high side. So each time you see a wear point, that's actually the high side. That's why it's not fitting together the rest of the way. So the difficulty with fitting these is you're actually taking this joint right here, and you're actually trying to push them together in opposite ways. You're actually pushing them like this, past each other. Probably one of the most interesting things is I'm always having to check just these little nuances of wear patterns. And then every time you start to file, you have to file accurately to maintain that same interacting lock. If you notice back here, where that weld joint is, you can see it's starting to square up. Mm-hmm. There is just a lot going on in this joint. And of course, me being me, I'm very particular. What I have to do is change the offset in order to get them to close properly.
It's horrifying.
It is actually. If you think about all that beautiful work and file work that I just put in, gone. Now it's all gone.
So you got to go back and file it again now.
File it again now. Yep. Someone asks me, usually at every show or whatever that I'm doing, well, isn't blacksmithing hard? It's not that it's hard, just some things take longer than others. It's all the same baseline skill set. And that really becomes the whole thing. It's not that it's harder, it's just that it takes longer. So again, what I'm looking for when I hold it up, you can see it's slightly undersized. So side to side, you can actually see a gap. So you can see now that that size is nearly smack dab on for where we're going.
What's that called again?
That's called this is actually a cold hardy, but it has the finest edge, and that's why I'm using it. I'm using it illegitimately. When you have really obtuse cutting edges on tools, there's a lot of pressure going into spreading it because of the angle, because metal is like clay, right? If you push into it, it wants to move away from it. When you have really obtuse cutting edges, it does the same thing with the metal. It wants to push it apart. So it becomes a problem that where my tools are very, very narrow, so you don't have that pushing apart effect. I want my head to be a little bit flatter, so I'm going to go in for one more heat. Okay, so I'm very happy with how that fits. I have a little extra material here that I need to get rid of, so we'll mark that. Ooh. That's much better. That side. Okay. So now what I'm going to do is I'm actually going to take a heat on that. I want to take a fairly fast heat so there I'm not distorting the rest of the pieces. Yep, that's peened nicely. Okay, so that's basically what we have right now. Hot rasp rasping is usually done hot. I use a hot rasp for many things because I use so many for doing the farrier work. So it's just a rasp, but technically they would be used for doing hot work. Okay, so that just needs a little bit of fine tuning. See, there's actually a whole formula on how this is supposed to look based on how the material is. So if you look, you can see that I'm about halfway. Here I'm a little bit over halfway in the leaf.
Yep.
See, that one's pretty good, that's pretty good. But see, this one's still a bit thick.
Yep.
So we need to get rid of that. Okay, so now I just need to finish up the tips. They would be ground. Traditionally, they'd be ground. So what they do is they would take the compass, get it to almost the finished state where it's done. They would harden it and heat treat it, and then they would just grind them. They wouldn't bother with.
So they're truly pointed.
Yeah.
So they're not